Good morning. I'm Alex Wuensche. I'm the person on the left side of the slide, and I'm here today to talk to you about the Bingo Radio Telescope and then 21 centimeter uh, cosmology that Bingo will be able to deliver. The Bingo Radio Telescope is a consortium from various institutions in different countries, and it's being coordinated uh, at USP by Professor Elsa Abdallah, the person on the right side of the slide, with the instrumentation part and the testing of the instrument done by INPI. We have a strong participation of Universidade Federal de Campina Grande, where the headquarters of operations will take place. This is located in Paraíba, northern part of Brazil. And we also have a strong participation of University College London from England, the Manchester University, also from England, and the Yangzhou University in China. Our main science goal is to detect the baryonic acoustic oscillations, BAO, in the redshift band that Bingo will be able to operate. We will cover the redshift interval between 0.13 and 0.45, corresponding to a frequency band between 980 megahertz to 1260 megahertz. Um, in, uh, in time, this covers from 9 gigayears to 12 gigayears roughly. So we are observing the universe at a much closer to our time than, say, the cosmic wave background measurement, which is way back in time. We will do these measurements through intensity mapping. That's a measure of the integrated emission of all hydrogen in the field of view. And this frequency band, this redshift band where we operate, has a very good superposition with many of the important optical surveys that are ongoing and that have already measured the BAOs in the optical waveband. So as I said, we will measure BAOs on top of the 21 centimeter H1 spectrum. So we will cover this redshift volume with a quite good sensitivity. Very likely we'll be able to reach 45.5 microkelvin after 1 year of observations. And the H1 intensity mapping that we do will be used as a mass tracer, baryonic mass tracer. And we'll be able to probe distortions redshift space and very likely to measure the radial BAO signal. Our final product should deliver maps in different redshift bands, 30 or 40 bands, and we will deliver as additional science data from the life history of hydrogen in this time interval. We will be able to measure radio recombination lines, and as part of our component separation efforts, we will deliver maps of the galactic continuum in our frequency range. Mostly, the most important contribution comes from synchrotron emission and free emission. We will also be able to do a catalog of radio sources, the most intense in our frequency interval, but also a map of the diffuse emission of unknown radio sources. And as a gift, as a free product that Bingo will get is the measurement of fast radio bursts in our field of view. The Bingo scanning strategy is drift scan, so we take advantage of the Earth's rotation in front of our field of view. So the sky passes in front of our instrument every day. We are able to revisit the same patch of the sky every day. And our first estimates indicate that we'll be able to measure or to detect one fast radio burst roughly every 3 days, delivering at the end of 1 year probably a list of 100 events. Our current status is, despite of the COVID-19 pandemic, is quite in time. We received our first funding in December 12, 2016, and we already have received a prototype completed. We have a feed horn that was manufactured and tested in Brazil. The mechanical design is also Brazilian. The electromagnetic design is British. We have the front end already set and tested. And we have a receiver. The test is all going, but we have the receiver, the radiometer chains already tested and working. We are trying to improve the receiver performance, checking different components. The optical design was initially done in France, but Brazilian collaborators took that in hand and finished the optical design. So this is the final design is a Brazilian contribution as well. And we will operate with 28 horns in the focal plane. Our system is very common in cosmic microwave background measurements. We use a cross-dragon system, two mirrors to guarantee that the primary mirror, the one that's inclined in the dark blue in the right side of the picture, that has no blockage from the secondary or from the horns. And these are large mirrors. They are 40-meter diameter in the paraboloid for the primary and 34-meter diameter in the hyperboloid in the secondary. Our receiver will operate at system temperature. We already measured the 70 Kelvin system temperature. We will likely reduce this somewhat using Peltier cooling. Our focal length is quite compact for this the size of mirrors. We have a 63.2 meter focal length. Our fluid have maximum is 40 arc minutes. That's a scale that's suitable to check for the BAO oscillations. As I said, sensitivity is about 45.5 microkelvin after 1 year of observations, and we will cover somewhat more than 1/8 of the sky at 60,000 square degrees. Bingo will be located in Paraíba, the northern part of Brazil. The coordinates are at the bottom part of this slide, 7 degrees south and 38 degrees west. We operate in a very clean area. We don't have mobile telephone towers in the field of view, and we don't have too much population around. It's a very uninhabited area. As a problem, we are very close to the equator, so you have straight illumination of geostationary satellites, which can be a problem in the data analysis. But we are confident we can handle that. So our schedule is to start operating at least one receiver, so a full receiver front end plus horn plus a digital back end that will do the Fourier transformation of the signal in the Bingo bingo frequency bands. We expect to have this for the first slide of at least one receiver by the end of next year, 2021. Um, there may be some delays due to the pandemic, but we have the site already in preparation, and we have most of the engineering projects completed as of today, September 4, 2020. So I thank the organizers of Iwara Conference 2020 for the possibility of delivering this talk. Um, Thank you very much, and I wish you all a very profitable uh, virtual meeting. Thanks.